Alright, the UV380 voltage regulator. The frame of the Westinghouse UV380 voltage regulator is specially treated soft iron parts to obtain good magnetic characteristics. The armature which carries the moving carbon is supported by a stainless steel hinge spring, which is spot welded to it. The armature rock with the two stainless steel balls, which are pressed into the edge of the frame to the top plate. Two arms of the hinge spring fit over the dowel pins to the top of the plate in order to accurately maintain the air gap between the bottom of the edge of the armature and bevel bottom plate. The stationary silver contacts are supported with the brackets mounted with a regular base panel in such a manner that the carbon contact may move freely between them. The moving of the carbon contact is supported by the insulated mount, which is fastened securely to the regulator armature. The current is carried to and from the moving contact by means of insulated flexible shunt. The regulator coil assembly comprises two windings, a shunt winding having approximately 13 ohm resistance and a series winding approximately 5,000 ohm resistance. The shunt winding is connected in series to a resistor directly across the generator output leads. The series winding is connected in a series with lead acid battery carried on the vehicle. The calibration spring has hook which fits over the notch knife edge of the armature. Some of the combination of the knife edge and the ball pivots ensure friction free movement necessary to satisfactory regulator operation. Adjustment into the regulated voltage are made determined with the kerneled nut which control the tension of the calibration spring. Description of the operation. The operator starts with the MG set with the closing the MG control switch on the front dash of the vehicle called the contactor to pick up and connect with the motor end of the MG set to the trolley voltage. The MG set will start with the rotating first with the generator voltage will below the setting of the regulator. Consequently, the regulator calibrating spring will hold the moving carbon contact against the right hand stationary contact. The generator shunt field series resistor is short circuited and the generator feed will be at maximum strength. This is illustrated in figure 1. As the generator speed increases the output voltage drive of the rising generator voltage applied with the shunt coil of the voltage regulator through its series resistor. The magnetic field set up the regulator will increase the strength until the position is strong enough to move the regulator armature again for the pull of the calibrating spring. When the armature moves, the carbon contact will leave the right hand stationary contact and the series resistor will be inserted into the generator shunt field circuit. See figure 2. Insertion of the resistance of the generator fields will cause the output voltage drop of the magnetic strength. Alright, so it says the generator armature, positive negative contacts, calibration spring, shunt field, resistor, generator shunt field, and ground, generator armature, ground. Figure 1. Ground, generator armature. And then you have your calibration spring, regulator series, regulator shunt field, contactor, and with an extra resistor to the calibration, the shunt field series. Alright, the regulator coil will decrease the calibrating spring will pull on the carbon contact again for the right hand stationary contact once more with the shunt resistor that again short circuit with the generator will rise. The carbon contact will move to and from the stationary contact, regulating with the generator voltage to the value determined in the tension of the calibration spring. In the event of the generator overspeed with the minimum loading over the generator circuit described will not be sufficient to maintain the described voltage, the problem provides for the control under these conditions. A resistor connected by the left-hand stationary contact of the ground armature is carbon contact moved with the right-hand contact resistance plate within series of the generator field. Now with additional contaction resistance is shunted across the generator field, weakening it still more. The circuit will now be as is in figure 3. The actual practice was found with the arrangement of the regulator shunt operating coil with the associated resistors not entirely satisfactory. Quite appreciable changes in the generator voltage resulted in moving contact oscillated time between the two fixed contacts. It was found that the addition of a fourth resistor would cause the moving contact to flutter against the stationary contacts. Trips. This made explained by the calculating the voltage at each end of the 1200 ohm resistor for the various contacts and positions. Alright, this figure 3 shows the shunt field resistor generator arms and then the shunt field parallel resistor and then the regulator shield resistor on the side. Alright, and then figure 4 shows the anti-hunch resistor. finding the current through it. The current will affect the magnetic strength of the operating coil will have been seen in each case with the change of the current of the operating coil from the contact made with the contact broken either side so much encourage the contacts to remake. Regulator used on the PCC cars will have the moving contact vibrating lightly against one another stationary contact. The vibration is evidence of light sparking on the contact surface. The rate of vibration and the length of the time during the contact touches it such that the average value of the field current is sufficient to maintain the generator voltage required voltage value. Figure 4 shows the anti-hunting resistor in circuit. Stated previously, a regulator coil assembly has low resistant winding of the connected in series with a car battery. The coil carries only a battery current, not in any other load current. Circuit is arranged that the series coil aids the regulator shunt coil, but the current of the battery will therefore tend to lower or droop the generator voltage. Our normal operating condition, the battery is floated across the generator, and the current through the series coil will be small. This causes only a slight reduction in regulated voltage. If for any reason the battery becomes abnormally discharged, the increased, and it shows, I'll flip this. Alright, it shows the ground armature and its ground. Then it shows the reverse current relays, regulator series coil, vehicle battery. Alright, charging current will result in the droop coil lowering the regulated voltage enough to prevent the battery damage. The regulator series coil connection is shown in figure 5. Under normal operating condition, the moving carbon contact will vibrate against left-hand field shunt contact. When the truck brakes are applied, heavy load will result with the carbon contact moving over and vibrating against the right-hand field boosting contact. Unusually low trolley voltage result in the MG set running more slowly. Under these conditions, all carbon flutter against the right-hand contact to the main generator voltage. Contact to maintain the generator voltage. The complete motor generator voltage regulator circuit is shown in figure 6. Technical data, shunt field resistor 17 ohm resistor taped at 15 ohms, regulator series resistor 78 ohm resistor taped at 65 ohms, shunt field parallel resistor 5 ohm resistor taped at 3 ohms, anti-hunting resistor 1200 ohms non-adjustable, generator shunt field 9 ohms, regulator shunt coil 18 ohms, regulator series coil 5000 with an ohm. And then we'll go over once more. You have reverse current controller, magnetic MG contactor, 25 ampere fuse, 600 volt supply, main generator, motor and generator armature with brown, and then 600 fuse total to all auxiliary loads, battery switch, and you had your series and your shunt, and your number 2 would be your hunting. And then this completes the reading of the UV38 UV380 voltage regulator.